Moving into the last stage of this morning, before we break for lunch, and delighted to have Dr. Cormac Quigley here with us from the School of Science and Computing, and he's going to take us through an advanced Moodle question design workshop. So good luck to the challenge. So looking forward to this. Thanks, Cormac.
Thanks, Karina. Yeah, it rolls off the tongue. So a bit more workshop than talk. You'll notice hopefully that I put into the chat there, for those of you who are on a device, I put in a link to a shared folder, and in that shared folder you can actually download the questions that I'm going to look at, so you can play around with them on your own time. And I put in a guide. It's by no means an exhaustive guide into how those questions work, but hopefully it leaves a trail of breadcrumbs so that some of you who are interested can work on getting into more advanced questions. So before we start and we think about what our aims are in having more advanced questions, because sometimes you get technology and it's like, oh well, this does shiny things, so let's do shiny things for the sake of shiny things. But if we think about what are we actually doing with Moodle questions, and it translates to other platforms, although this is very much stuck in Moodle, typically we want to ask the students a question. Please answer this question. And that is broad. It depends on your level, it depends on your topic, it depends on an infinite number of variables. But we always are going to evaluate then a response, because they have to input a response into the computer. And the kind of response that we can get can be really quite varied. But it's actually not the response that's important, it's how we situate it in their learning. And so we can have complex responses or simple responses, we can have abstract concepts, we can have concrete concepts. And where we situate those questions and how we relate that to the rest of the students is really what I think advances Moodle questions in terms of their utility, rather than having more complex. Although what you'll notice by the end of this workshop is that things tend to get very complex if you want to actually make things concrete. And it's this part where we can really advance what we're doing, is how do we analyze our students? How do we analyze our students' responses? Does the response match the expected input? And in terms of an expected input, the simplest way of thinking that is right or wrong. The response is equal to the answer or it's not. But actually, in reality, we know that in nearly every case, it's a much more continuous spectrum between correct and incorrect. And what really is going to set our questions apart is if we can get our feedback right. So if we can get our students the feedback that tells them where along this line they are, and what they can do to go further towards the correct, I know what I'm doing, I understand direction. So, not to talk too long about that, everybody's aware that there are lots and lots and lots of different question types. Everything from MCQs down to real world, multidimensional, really exciting, interesting, all sorts of grading structures. A few examples in terms of what I've done. Here is a very simple question. So this question asks the students to read the thermometer and tell me what the temperature is. It's nice because it sets the question in a very concrete way in something that they have seen. They know what that is and they can relate it to the real world. It's not abstract at all. It's simple and it provides feedback, yes or no. On the other hand, you can create really nice complex questions. So you'll gather by now that I'm a chemist and a lot of these examples are chemistry based. But here I'm asking the students to understand this scheme, this organic reaction mechanism, and output an answer. And you'll see that if you use and if you're in ATU Galway, these question types are available. Hopefully in Sligo and Letterkenny they will become available, and you can discuss with your own Moodle managers as to how to get these in. They're all open source, freely available, but the students are asked to draw out the next step in the scheme. That definitely goes in the complex and abstract. Even though these questions are not very difficult to set up, you can go anything from concrete, getting more difficult. But where it gets really interesting, and what I want to focus on, is this idea of formula questions. So I'm going to look back at this, and I don't expect you to be able to read that by any means. But what this is a student's lab book, but as a Moodle question. So the student is being asked to input their own lab work into Moodle. And what we'll see later on in this is that we can actually grade each individual student's lab work relative to what they have done themselves. So the expected answers aren't actually known in advance. All we know is that the student has gone into the lab and measured a bunch of things. But what we do know is the relative relationship between each of those answers. If a student measures a value of 10, then they should end up with a recorded output of whatever that happens to be. And so we can program that into our question, and then we have a really interesting look at how students behave. It doesn't have to be this complex, so it can be nice and simple too. So let's actually have a look at what I think the most important part of this is, which is the feedback. Because if you're setting a Moodle question, it's all about what the student gets back afterwards. If they just get it right or wrong, they're not going to know very much. And it doesn't have to be super complicated. So here's a relatively simple example where I set out a numerical question and I asked for an answer. And I know what the answer is in advance. There's only one possible answer. But I also know that there are a bunch of pitfalls that these students can make along the way. So I'm expecting an answer of 0.65. I know if they're too low, they've made one mistake. If they're too high, they've made another mistake. And if they're out by a little bit, they're just not doing it quite accurately enough. And if I relay that information back to the student, something really interesting starts to happen. This is the question, and I actually asked them to measure how far up the plate is this versus how far could it have gone. 259 students did this. Initially, 68% of them gave at least one answer which was wrong. After going through the quiz, we got those down to 10% getting a wrong answer and 7% getting a wrong answer in their final attempt. So you can actually see the feedback generate learning in the students. I suppose people would like to describe this as assessment as learning. But if you set your question up, this is not a particularly complex thing to do, but if you get your feedback right, then you can actually see the learning happen. Of course, the feedback, that's us giving feedback to students and then taking our own feedback from it. And next slide. Oh, something's popped up. Sorry. I don't know what's going on with the clicker. The clicker has suddenly stopped working. What we're looking at here is, feedback in terms of how it can affect the students. But what I suppose is also important is that we are seeing that feedback as lecturers, and that's also informing our teaching. I'll use the keys, it's grand. Okay, no more clickers. So you can do that for lots of different question types. This is another example. This is a short answer question, and you can see for answer 1, the expected answer, they get 100%. If they make a conceptual error and they misnumber it, they only get 60%, but they get feedback telling them that they have misnumbered it. And you'll see this in answer 5. There's actually a whole range of different possible errors that we know the students can make. So the point in advancing your Moodle questions here is not that this is difficult to do, it's just that when you set out your question, rather than making lots of questions, make lots of feedback, and that will advance your students, from my perspective. Anyway. Where it gets really interesting then is that we can look and see what the student answers are. So if you, if you look at the responses from a quiz, you can look at however many attempts are made, and you can download the responses, click on 1, click on 2, and as, I don't know if Rachel McCarthy is watching this, but this is a phrase that she brought up, who dares to teach must never cease to learn, is that you have to keep learning from what your students are telling you. So you can download all this information and you can start to plot it. And what gets really interesting then is if we make our questions about real world examples, we can start to plot how our student behavior happens in the class. We can see here in a lab, I've asked 218 students, or at least 218 students have actually done the lab. They've put in the results and they are giving this set of results. And we can see that 22% of students haven't managed to get a reasonable answer out of the lab. This distribution, so it's a one-sided distribution just because of the way the data has been analysed, shows that there are a good portion of the students getting the correct answer, and then there is another portion of students who are normally distributed around some other answer, telling me that there is some common misconception in that class where they are doing something that gives them a definitely wrong answer. And if I can figure out what that is, I can enhance my teaching. So if you change or if you create these kind of questions to gather real world data from students, you can really use it to look at, reflect on, and change the way you run a lab. It's not limited to chemistry, it's anything where students gather information and then later process it and give it back. So this is that same question, and we're still not going to pause and look at it, but in this case, the students are asked, well, what did you measure? Put in your inputs and then do the calculations. And it's nice because you can do this. There's lots of labs and you can observe student behavior over time. So on the left, this is the very first set of results that the students give back. And you can see that this is pretty much just a random scatter of results between 14 and more than 32. And on the right-hand side, again, you can see that it's more or less normally distributed around what we would expect the right answer to be, but there are some outliers. So you can literally watch the progress of your students as they get better at a given technique. If we set up our questions to get in data from the real world rather than just asking them abstract questions, which is what the second half of this is about. How do I get a formula question to take data from the real world and process it and mark it correct or incorrect for a student? How do I take a lab book that looks like this and convert it into a question that looks like this? And what's going on behind the scenes? And so this workshop is really all about formula questions. The first thing I'm going to say is that formula questions are hard. All of the other examples that I've shown, drag and drop questions, calculated questions, all the other question types in Moodle are relatively simple compared to Moodle formula questions, which are hard to program. What I've put up in the shared folder there is 6 example questions in increasing order of complexity. So if you want to, you can download them and you can work your way through them. I also put in, there's a PDF there with kind of a guide explaining some of the points in each one. This is a workshop, but not really a workshop. If it was a workshop, it'd be 3 hours long. So instead, what I'm going to do is just guide you through some of the points, lay out the trail of breadcrumbs, and see if that's something that is of interest. So if you set up a formula question, what it does is it actually gives you control over pretty much every aspect of the question asking process. Rather than in a normal question, say a calculated question where you just put in your answer and say, does it match or does it not match? In a formula question, you can define how that answer is related to what the student puts in. So it doesn't just have to be, is it equal to or not equal to? You can say, is it equal to that plus also consistent with an earlier answer a student gave? Or you can say, where does it fit on a sliding scale? So rather than just having a right-wrong answer, you can grade a student's result as how close to the real answer did they get. 100% if it's right, sliding down to 0% if it's way out of spec. And then we can start doing this where students put in their real-world information. So just briefly to give you some idea of what these questions look like, this is a formula question. This is, for those of you who are familiar with Moodle, this kind of screen will be really familiar to you in that you'll have said, well, I've made lots and lots of questions. But there are some really key features, one of which is that you can create things called grading variables. So rather than just saying, here is my answer, you can create these different variables which evaluate using Boolean logic as to whether or not the student answer meets the criteria that you want. And those criteria can be whatever you like. So on the first line here, the first answer, which is _0, has to be less than 1.21 and greater than 0.99. I'm just checking, is the answer in range? And you can set out whatever level of complexity you like. So you can have as many criteria as you like. Well, I don't know of as many, but I haven't reached the limit yet, and I have put in lots of criteria. And then you can assemble those criteria into whatever combination, permutation you happen to like. So here I'm saying that, well, the student has to have a relative error of less than 0.2. So their error has to be within 20%, and they have to have this criteria, and that criteria, and that criteria, and this one or this one. So I can have ands, ors, not ors. The choice is yours. And like I say, this can get very complex very quickly. So let's maybe start at something a little bit more approachable and then work from there. The other thing is that with these questions, you can actually throw in an MCQ answer as well. So it facilitates other question types internally. It's a little bit like close, except that you've got an awful lot more control over what's actually happening. So this is just an example of an MCQ question. And you can see here, if we look at how it's programmed, this is the text of the question. Here's an image of what's going on. And then the student answer is just make a choice out of this list of choices. And I tell it in advance what the answer is. Okay, so at this point then, this is just the URL that I already pasted into the chat. How are we doing for time? We're doing all right for time. If you want to open that folder and have a look in there, if you are on a device, I know most of the people in the room are not on a device, so they're not really going to workshop this. But if you are at home on a device and you want to actually follow these through, if you click onto this, you'll find a shared folder and you'll see that there's 6 different example questions. So they're Moodle XML questions. You can upload them into whatever question bank you want. And there's also that document, and these slides are in there as well. If after this 15 minutes, I've piqued your interest. I have some videos that I have made previously down here. You can follow that, or you can actually just search on YouTube. And it explains in more detail some of the aspects of making formula questions. But in any event, what you want to do is open up a Moodle page, open up your question bank, and create a new question. And you'll see this formulas question with the little x equal to y equal to symbol. And once you do that, then you should get something like this. So you get a question, and like many things in Moodle, there are an awful lot more options than you might ever think you need to use. So, sorry, I'll stay in camera. Just briefly, what I would suggest is, rather than trying to make a question the first time, that you will not be able to save your question until you actually have a complete and valid question. And I would not like to admit how many hours it took me to actually make my first complete and valid question and be able to save it. But you have to make sure that you have all of the parts in there and that they actually compute into a valid question before it'll let you save it. There is a very steep learning curve, which is why I would suggest downloading one of the samples and going from there. Because once you get over that learning curve, you have really, all sorts of possibilities in terms of how you can analyze and grade student information, and then you're back to being able to monitor classes as a whole. You can set out whatever variables you like, and you can set out your question text. You can have as many parts as you like in your question. So the first two parts let you set out, when I say a variable, I mean either a number or a list of things or an array or a string or whatever. Depending on how much computer science you do, some of those terms will be more or less familiar. After that then, each separate part is graded as a separate question. So you can set out as many questions or as few questions as you like inside your one formula question. We're not going to bother with the extra options. What's really nice about this is when we talk about variables, you can set out a random variable. So one of the issues with making Moodle questions is that if you have to make 100 Moodle questions, that's a lot of time. If you make one question and you can have essentially infinite variation within that question, then that's really great. But if you make infinite variation within that question and you don't define the edges of that well, then sometimes you get questions that don't make any sense. So how many euros do I have left? Minus 15. That doesn't really make sense in a real world context. And what you can do is check your variable instantiation, or basically check what the variables compute to and see, does my question make sense? And then we're back to feedback, and that is obviously very important. So what I'm going to do actually, sorry, before I look through that, is skip across here. Okay, so if you have uploaded one or any of those questions and you've put them into your question bank, you should see them here. And you'll see they're all very chemistry focused questions, but that doesn't mean you can't adapt them to whatever you want. And what I want to do is just look at the simplest of all of those questions, which is the Ka calculation. So if we preview that question, it looks like a very simple question. Given this, what's that? So I'll have a zoom in there. Given a pKa of 5.04, what's the Ka? Simple in terms of maybe you don't know what it's talking about, but and number in, number back out again. Sorry. So if we actually look at what the inside of that question looks like, you'll see more or less what I was talking about in the slide. So you'll see that you have your variables up the top. And in those variables, we set out two variables. We can set whatever we want in here. Our random variables will be randomly picked every time the question is opened. In this case, a number between 4.2 and 5.9 to the nearest 0.01, so to 2 decimal places. And our global variable, well, you don't have to set any global variables if you don't want, but in this case, A, which is going to be the answer, is 10 to the power of minus P. So we have our variable set up, and then we just set out our question. Given a pKa of, and then you probably possibly can't see those depending on your screen resolution, they're curly braces. Given a pKa of P, so this variable P will appear in the question. What is the Ka? Curly braces underscore 0 shows that's where I want the answer to be. And in this case, all we've said is that the answer is A, and the student has to get it within a relative error of 0.01, or has to be within 1% of the right error. That's a really simple question, but instead of having to make lots and lots of different versions of that for a calculated question or a numerical answer question, every time the student opens that, they're going to get a different starting number between 4.2 and whatever the 5.9 or whatever was set in the initial. That's kind of the very simple end of things. Where things start to get really interesting then is, just go back, when we start to add complexity. So I said, you know, you can take things and you can grade relative, you can grade on sliding scales, and that brings in something else entirely, which is the grading variables. So I'm just going to pull up this question, which is the molar mass sliding scale. And this question is very similar. It asks the student for a single value. So what is the molar mass of the acid you used in your titration? In this case, for context, the students do a whole lab and they should get a single value at the end, and that value, however close it is to the real answer, is a good measure of how precisely they worked in the lab. So all I've asked for here, there's no randomization, there's no random variables, there's nothing, there's just a single box, enter in the number that you got. The question is, how do I want to evaluate that? So what is my grading going to look like? And in this case, there are different things that should happen. So if you have a student making real world measurements, then we know that things have limited precision. There has to be some scope for a student that gets within a certain amount of the right answer to get 100%, which is case number 1. The error, if it's less than 5, well then I think the students should get 100% of the marks, because that shows they've used the glassware and the materials available to them more or less within the precision that they had. Where it gets interesting then is that if they're more than 18 away from the right answer, I think they should get 0, because I think they haven't used it. But as you go from 5 to 18, maybe rather than putting the students into groups, maybe what you want is a sliding scale. So to implement that sliding scale, what I have done is I've said that 1, which would be 100%, minus 5 times the relative error. And the relative error goes from 0 to 1, well, 0 to more than 1, but by the time you hit 1, you're more than 100% away from the right answer. If I multiply that by 5, then if they're within 20% of the right answer, they get some amount of marks. Now, you might say, well, these conflict with each other, because if we meet this, then we can also meet this, and we're getting different grades. But they're the 3 possibilities. Either they are within 5 of the right answer, they get 100%. They're more than 18 away from the right answer, they get 0. Or they are between 5 and 18, in which case they get a sliding scale. And actually that sliding scale descends a little bit too fast, so I say, well actually if they're within 18, I still want them always to get a passing mark. And all that I have to do then is, describe that, and zoom in there a little bit, in my grading criteria. So I give the students the most of case 1 or case 2 or, well, case 3 by 40%. So they can get 100% of the marks, somewhere between 140% of the marks, 40% of the marks, or if they don't meet any of these cases and they've just got a totally wild answer, they get 0, they get no marks. But what's really nice about that then is that the student in real time gets an assessment, and an honest assessment, not from a lecturer in a lab, of how good their lab work is. They can actually measure against some objective scale, am I using the glassware correctly? Am I making a measurement that is valid, is sensible, is good? Or am I not? Okay, time is precious, so I'm going to show you one more example, and I'm going to show it to you, not that we'll ever explain our way through it, but that it'll give you an idea of exactly how far you can take this as a concept.
Cormac, there's one question.
Yeah.
I see that Kevin has just posted up there. Do you know of any open source resources, question banks for other sciences or subjects, other disciplines that have been developed to the similar level of yours, or some or all of your questions?
Yeah, I'm happy to share all my questions. They're all very chemistry. If you go to moodleformulas.org, it's the central resource, and it is well, one of the great criticisms of these questions is that they are not adequately documented, but there are lots of sample questions, a lot for maths, physics, I think some for biology, definitely some for engineering, and you'll find lots there. But I'm happy to share more of these questions. I just put up the 6 there to try and pique some people's interest. Okay, the last one that I'm going to show you, which is this post-lab question here. So this is one of the questions that I just threw up and said, oh, you're never going to be able to follow it. Well, here we can see exactly what kind of thing is going on here. So there are no variables, there's no random variables. This all depends on the student's lab work, and it's divided out into 6 different parts. And if we just take one of those parts, let's take part 6, for example, and I've weighted it at 1.5 versus the other parts. You can weight them wherever you want. What I've done is I've set out criteria where the criteria reference back to what the student put in the first place. So criteria 1 says the absolute value of 20, which is the expected value, minus underscore 0, which represents the student answer, has to be less than 15. They have to have an answer that is in some way valid and shows that they're answering the right question. That's a basic criteria. What follows then is that the subsequent answer, underscore 1, has to be equal to the first one divided by 1,000. And that relationship is because they're converting from litres to millilitres to litres or whatever. So that's a definite thing. And then the third part says, well, this divided by that, also a known relationship because I know what glassware they're using. And by using these criteria, then the students have to rigorously and definitely get the lab work correct. And they can try it as many times as they want. So they know when they're getting it right, and they are tormented until they do. And sometimes you do get feedback from students saying, oh, I thought I had it right when I left the lab, and it keeps telling me I'm wrong. And what I tell them is that, well, you don't have it right because it is not objectively correct, usually in kinder words than that, and to keep trying, and let's look at where they get it wrong. And when they make that leap and say, oh, well, I know where I went wrong, and they then get it right, that's usually a good part of satisfaction. And this kind of thing takes away the idea that they're just working with numbers that don't matter to them, because they know that they actually made that measurement, and they have to take the measurements they made and make sense of them. And so these formula questions are a really useful way of doing that. Now, I suspect it's obvious to anybody who stuck with this for the half an hour that you could talk about these probably for hours and hours on end to try and get your head around how to actually write them and so on and so forth. And that is true. So what I'm not hoping is that anybody is now able to make these questions. What I am hoping is that I've piqued some people's interest and given you an insight into maybe a little bit how they work. If you are interested, send me an email and I can send you on questions, or visit moodleformulas.org. And then these are things that I have already said. Is this actually going to... Sorry. So, last slide. Thank you for listening. Yeah, you can find videos on it there on my YouTube channel, or like I say, email me and I can send you any number of questions, or moodleformulas.org. And you'll find a whole range of people across the world have submitted different open source questions. Any questions?
We're now ATU.
I must have made these slides before the 1st of April.
I think there was another question there, wasn't there, from survey?
She was asking if there was a guided book or navigator for starters from where to start, or is moodleformulas.org, does that have beginner guidance?
There's not really a lot beginner about. That's one of the, what I would recommend is just taking a question that you know works and tinkering around with it, because if you try write them, you can start from the beginning and just try and write them, and Moodle Formulas does have documentation on how to do it. It's just a lot easier if you have something that works and you can break it and fix it and break it and fix it. And there are questions up there, and there's endless documentation up there. If you have some computing experience, it's easier because a lot of the language, a lot of the way the variables are used and the Boolean operators and stuff will be familiar. But even if you don't, it's up there. So yeah, moodleformulas.org. I think I put that in a slide.
One more
Yeah, sorry.
Mr. Cormac, yeah. So what are the logistics? Let's say you have your Moodle formulas as like a lab source. What's the logistics of using that in the lab? Do the students do any calculation in the lab? Do they take
No.
the measurements and then go home? And
Yeah,
analyze
they take the measurements, fill them into their lab book, and then go home and analyse them. And often they will actually do some of the calculations pen and paper in the lab, but then they still have to go and put those into Moodle afterwards.
Do you find sometimes maybe they measure the wrong thing, or they realise they make aims for measurement?
Sometimes, yeah. I try and be pretty strict about, and it says on a lot of the questions, submitting other people's answers is plagiarism, because I want them to accept that what they have done. You know, they've made the measurement that they've made, and if they've made a mistake, they'll learn from it. You know, and they're not doing the quiz is worth more marks than actually the marks they get for getting it right or wrong. So it's more of a learning experience in some ways than it is, you know, it's first year chemistry in this case, so it's not very high stakes, and they have one of these a week, and they have a pre-lab a week, so like they kind of just get into a habit of it. But like those kind of things are very much up to, if you want to deploy formula questions, you can do whatever you want with them, you know, in some ways. So, but for me, yeah, it's kind of, if they get it wrong, they get it wrong. And that's, you know, sometimes you do work in a lab and it doesn't work, as you probably know yourself, you know, you bang your head off a wall for a while. So it's a learning experience too.
And just the final thing, someone was asking, do you need any programming here? I'm assuming they're asking, do you need programming skills?
No, there is a bit of a learning curve getting used to, like, what does it mean by a variable, and just, there, like, again, if you go to moodleformulas.org, they have a list of all of the different operators. So if you want to say this is more than this, or this is, or this, or that kind of stuff. And if you look through the example questions, you can kind of put those two things together and see how they are done. And you will learn some, I wouldn't say programming skills. I cannot program. It is not something I can do. But you do learn logic, yeah. Some computer scientists can help me out here, thank you. Yeah, you learn logic, and you learn, you know, how to create the questions. Any other?
All right.
No?
Thanks.
Cool, thanks.
Thanks, Cormac. And we'll see you this afternoon.
Yeah.
You're down again. So thanks very much. We're going to take a break for lunch, everybody, and we will be back live at 2 o'clock.